Hello everybody, and welcome to this video on motion equations and how to solve physics problems using these equations. To begin with, from our previous video, we went through and we made all the motion equations. I just want to reiterate them here. The ones I have in the box, these are going to be, let me go back here. So the ones in the box here, these are all of your equations that you use when you don't have acceleration, okay? So the speed is distance over time and velocity is displacement over time. So when an object is going at constant velocity, this is what you're going to be using, okay? Anytime an object is accelerating, meaning it's speeding up or slowing down, such as a falling object or a race car getting faster, then you're going to use one of these three kinematic equations. And to determine which equation you're going to use, you're basically going to follow these steps here. So first of all, you want to list all the variables given. So list all the variables. Some of them won't be as obvious, like if they say it starts from rest, VI is going to be 0. Okay. Also remember, if it's a falling object, A equals little g, 9.8 meters per second squared, if it's a falling object on planet Earth. Okay. The next thing is you want to determine what are they asking for. So what is the question asking for? Always put a question mark next to that variable. So what is the problem asking? Okay. Then you want to look at all the formulas and find the formula that has everything you need except the one variable. So next you want to write the formula. And then next you want to sub in with all the values in units. Make sure the units match. And then most of the time it's just going to be algebra. You want to solve for the unknown. And your final answer you want to check, does it have the correct sig figs and units? Okay. Normally, if I'm grading a problem, let's say it's a 6-point problem, for finding the correct formula, you're going to get +2. For substituting in the values and solving, you're going to get +2. For your final answer with the correct sig figs and units, there would be your +2 there. Sometimes this will be worth 4 points or whatever. So actually, more often than not, this might be 4 points. So you got a point there, and then 2 for the correct answer. Okay, so that would be a typical 8-point problem. But if you didn't have this at the beginning, you're not going to get credit. So you always got to do that at the beginning there. Which brings me to a point. I don't want you to get the idea that physics is simply find the correct formula and plug in the units. They always nickname that plug and chug. That is not what physics is about. This is simply a tool to help you solve some of the physics problems. And hopefully you don't get the wrong idea that physics is just a bunch of story problems and you just got to find the right formula, because it's so far from the truth, okay? Like I said, this is a tool that we need to learn how to use, but physics is much more than just this, okay? So anyway, let's jump right in, and let's start off with something like this. It says, a racing car starts from rest and reaches a velocity of 35 meters per second in 4.5 seconds. What is the car's acceleration? So you write down the variables. It starts from rest, so VI or V naught, depending on how you use that. It's going to be 0. And then it reaches a velocity. That's going to be VF, your final velocity. It's going to be 35 meters per second. And your time is 4.5 seconds. And they got to find the acceleration. That's your unknown. So you look at those formulas, and the one formula that fits the bill that has all of the variables except the one you need is going to be this one, your definition of acceleration. So you write the formula. Acceleration is VF minus VI over your total time, delta t. And then you substitute in your values. So your final velocity is 35 meters per second minus your initial velocity 0 over 4.5 seconds. Okay, and when you divide that out, you'll get an acceleration. You might have 3 or 4 digits in your calculator, but you can only have 2 digits in your answer because you have 2 sig figs here and here. This is not a sig fig. That's not a limiting factor. Okay, so you should get about 7.8 meters per second squared. which is a pretty high acceleration given that gravity is 9.8. Okay, so there's your final answer with the correct units and sig figs, and that's how you'd work that problem. Okay, each problem usually gets a little bit harder here. So now a car is traveling 35 meters per second. It brakes and decelerates at 7.5 meters per second squared. So it's kind of taking that last problem the next step. So VI is now 35 meters per second. Okay, A, while it's decelerating, is 7.5 meters per second squared. Now you got to understand here, since our velocity is positive, we're traveling to the right or to the east. The braking is in the opposite direction, so that's going to be negative. Don't just assume braking is always negative. If that object were traveling to the left at negative 35, then I'd make the braking positive because it's acting in the opposite direction there. Okay? They want to know how long does it take the car to come to a stop. So VF is going to be 0 because you're coming to a stop, your final velocity, and they're looking for time. And then that's going to be part A. Part B, they want to know how far does it travel. Okay, a lot of times students try to make the mistake to solving it all in one step. This is going to be two separate problems to solve this. I'm going to use the formula we did first to figure out how long it's going to come to a stop. I'm just going to use same formula, just rearrange. VF equals VI plus AT. Now some people like to rearrange it to get T by itself. That's up to you. It's probably better if you do that, but this will be fine. So I'm going to substitute in the values. The initial velocity is 35 meters per second minus plus negative 7.5 meters per second squared times t. So bring that to the other side of the equal sign. You get negative 35. I'm running out of room here. I should put my units, but not going to have enough room for everything. This is negative 7.5 t. Divide both sides by negative 7.5, and there will be your positive time, which it should be. So the time you're going to get comes out to be about, with two significant figures, 4.7 seconds. So that's how long it's going to take to come to a stop. Okay? To get part B, what's the distance you travel? Okay, once again, you look at all the variables. You can put 4.7 here. This is now one of the variables you have. And you figure out what formula is going to be the best to solve that problem. There's actually, you could use this formula. Distance equals VIT plus 1/2 AT squared, and solve for your distance. Or you could use this formula, VF squared equals VI squared plus 2AD. And I shorten that D is technically X final minus X initial, but you can just use D in this situation. Either one of these formulas are going to get you the same answer. This is an easier formula to work with, a little fewer variables. So we're going to go with that one. So once again, we write the formula. VF squared equals VI squared plus 2AD. We're coming to a stop. So our final velocity is 0. And our initial velocity is 35 meters per second. And that whole quantity is squared. Plus 2 times our acceleration is negative 7.5 meters per second squared. And we're looking for our displacement. So you're going to square that, bring it to the other side of the equal sign. It makes it negative. Multiply that by 2. You get negative 1225. And that becomes meters squared seconds squared, because you're squaring each of those values, equals negative 15 meters per second squared times d. Okay, divide both sides by negative 15, and the seconds will cancel out, and that meter will cancel out one of those meters, and you end up with distance being in meters. So your distance will be a positive 82 meters to come to a stop with 2 sig figs, correct units, and there you go. So it took 2 separate formulas to solve that, but that's how you solve those particular problems. Okay, let's try one more. says a person drops a penny off the top of the Empire State Building 440 meters above the ground. How fast is the penny traveling when it hits the ground? Now, after it hits the ground, its velocity is 0. They want to know the impact velocity that it has when it hits the ground. So since it drops the penny, they're not throwing it down, your initial velocity is 0. When you first drop it, it starts at 0. They don't really say that in the problem, but had he thrown it down, they would have given you an initial velocity. But since he dropped it, the initial velocity is 0. We're looking for the final velocity. That's our unknown. Okay? We have the height, or the displacement, is 440 meters. And it's assumed to be on planet Earth. We're the Empire State Building. Always assume it's planet Earth unless they otherwise say. So we have the acceleration. It's gravity. 9.8 meters per second squared. Okay? So this is going to be just like that last problem here. Your best formula to find this problem is going to be Vs squared is Vi squared plus 2AD. Substitute in your values. We're looking for Vf squared. Our initial velocity is 0. 2 times negative 9.8. Sorry, we're going to make that positive. I'm going to call down as positive on this. 9.8 meters per second squared. And I'm running out of room here. That D is going to be 440 meters. Okay, so you multiply all those together, you're going to get Vs squared equals 8624, and that becomes meters squared seconds squared. You notice I don't worry about sig figs when I'm doing my problem. I put all of my numbers when I do my calculations. You only round at the very end to two significant figures in this particular problem, because 9.8 is 2 and 440 is 2 sig figs. That 0 is just a placeholder. Okay, so to solve for this, the Vs squared, you need to take the square root of both sides, reduces that to that, and the square root of 8624 turns out to be about 93 meters per second. Which, if you were to convert that to miles per hour, is a little over 200 miles per hour. Now, in reality, that's not going to happen. A falling object on planet Earth is going to accelerate at 9.8, and then eventually it's going to hit terminal velocity. They call that V terminal. And then it's not going to accelerate anymore. It's going to fall with a constant velocity. But for these problems, we leave air drag out. So if there were no air drag and that were in a vacuum, yeah, it would be falling at 93 meters per second, or about 208 miles per hour. So, hope that gives you a good introduction. The only way to master this stuff is just to practice, 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 and that's what we'll be doing in our class time, okay? So follow your rules there, get as much practice in as you can, and then you'll find out these are a breeze once you get the hang of it. So, hope that clears everything up, and that ends this video here. Thank you very much, and have a great day.